Hello again everyone, welcome back to ptet.chemistry channel. In this tutorial video, I'll continue this section B kind of topical MCQ for section 9.3, which is on group 17 chemistry. So with this section B kind of MCQs, we are assessing three particular statements or three particular things related to whatever they're asking. So if all three are relevant to what they're asking, there's A, B is 1 and 2, C is 2 and 3, and D is just 1, being relevant to whatever they're asking. Alright, so I say relevant to whatever they're asking because it's not always they're asking for correct, because sometimes they say which one is not correct, which one is impossible, something like that. So it's relevant to whatever they're asking, yeah? So this question is actually fairly popular over the years, as you could see. It's not about how often it gets repeated, but it's about why do they want to repeat it that often. Partly because it's something that a lot of students get confused in previous years. Perhaps, okay, they want to see if your students have students across a different year group might have gotten it better through better teaching perhaps, or they are still as confused as ever. Alright, so which properties increase in that sequence? Alright, HCl to HBr to HI. So this is down to group 17. If I do bond length, well, the atoms are bigger because you have more shell. This is how you explain in paper 2, right? So the radius of chlorine is smaller than the radius of bromine, smaller than the radius of iodine. Therefore, the HX is longer. So indeed, the bond length gets longer, alright? In terms of number 1, we need to think about the energy, because related to what I've mentioned previously, as the covalent bond gets longer, the covalent bond also gets weaker. Okay, gets weaker. So meaning to say the energy of HCl, it's weaker than, it's stronger than the HBr. The HBr, it's stronger than the HI, and you can in fact get this value from the data booklet, or you can just think about this covalent bond getting longer, and therefore your covalent bond getting weaker. Alright, so because the covalent bond gets weaker, so this is weaker covalent bond, therefore less stable to heat. If you become less stable to heat, your thermal stability will decrease, because you become less stable to heat. How stable you are to heat will decrease, alright, not increase. So this is wrong. Number 2 is correct, number 1 is wrong. Therefore, you're left with option C, which is 2 and 3. And then when you think about ease of oxidation, how easy it is to oxidize it, alright? So we go for number 3. These are HCl, HBr, and HI we're talking about. So we're talking about Cl minus 1, Br minus 1, and I minus 1. I hope you know from a GCSE, IGCSE, or O level, Ki is very good reducing agent. It's a fairly powerful reducing agent. We are not talking about the halogen molecule, we're talking about the halide. I don't want that. We're talking about the halide, which is iodine minus 1. So this is a very good reducing agent. Okay, it serves favor oxidation, because reducing agent reduces other things, and therefore its surface is oxidized. Therefore, this will become the easiest to be oxidized. So going that way, the easier it is to oxidize the HI compared to HBr compared to HCl. So number 3 is actually correct as well, which we don't need to check really, because you know number 2 is correct, number 1 is wrong, number 3 is definitely correct. But in theory paper, they can ask you to explain, and I just explain it to you in that sense. Alright, so moving on to the next question. In this next question, this is very wordy again. Number of moles of chlorine, so this is Cl2, that react with 1 mole of X, is twice the number of mole. It's twice the number of mole that react with 1 mole of Y. Okay, so there's no other way. We think we gotta try and balance the equation. If I check for option 2 first, if I check for X, so H2 plus Cl2 give me HCl, so that's 2. So the mole of Cl2 is 1 here, okay, reacts with 1 mole of X, alright, reacts with 1 mole of X, so there's 1 there, okay, which means you only need 1 mole of Cl2 to react with 1 mole of X. Whereas the other one, KBr, I have 1 of these reacting with Cl2, I will get KCl plus, oh, hang on, oh yeah, chlorine is a stronger oxidizing agent than bromine, Br2, so chlorine can oxidize Br minus to Br2. And I'm running out of space already. Remember that you only want 1 mole of Y, so you cannot change this number. So what happened then is I cannot change this number, it has to be 1, and therefore it has to be half because I only have 1 bromine atom. So this will give me 1 bromine atom, and that will give me half of this, alright, so it's 0.5, or you can think about half. So that is Y, and it says the number of mole of chlorine that reacts with 1 mole of X, which is 1, is twice the number of mole that reacts with 1 mole of Y. So 1 is equal to 2 times, is equal to twice the amount here. So 2 is entirely correct, okay? So this question is very wordy, yeah? Anyway, so going on to the first one, Mg plus Cl2, give me MgCl2, because you have Mg2 plus and Cl minus. Your LCM, in order to balance the charge, 2 and 1 is 2, so you only need 1 of these and you need 2 of these. MgCl2, you cannot change this number here because they say for 1 mole of X, for 1 mole of X, alright? So you cannot change this number here, so therefore this has to be 1 because 1 magnesium give you 1 magnesium, so you get 2 chlorine, so that's already 2 chlorine, so it's just 1 mole there, alright? How about the Y? That is sodium there. So if I try sodium, so 1 sodium plus Cl2, give me NaCl, so Na plus Cl minus, so this would be half, this would be half, and again for X this is double, this is 2 times half, alright? So number 1 is again correct, alright? I can tell you 3 is wrong because I know this chemistry. This is called disproportionation, and if you revise your group 17 chemistry thoroughly, if you have done this balancing equation previously, okay, leading up to this watching this tutorial video, you will have known that they do not just double the amount of chlorine. It's not as easy as that, alright? And I'll show you why that is now, okay? Which ideally you should be able to anyway. So the first one is about cold and the other one is hot. So in cold, you would stop at chlorine minus 1 as your product and chlorine plus 1 as your product. Whereas with the hot, you get chlorine minus 1 and chlorine plus 5, okay? So those are your 2 different final products, chlorine plus 5 versus chlorine plus 1. The Cl minus 1 are both produced as well because the Cl2, which is chlorine 0, is both oxidized and reduced in these reactions because this is called disproportionation, where one species is both oxidized and reduced in the same reaction, alright? So being guided by that, you have Cl2 plus NaOH, so this is your cold dilute NaOH. You will get NaCl, which is your chlorine minus 1. You will get chlorine plus 1, which is your NaClO, and you will get water. Your job now is to balance the equation. So chlorine 0 to chlorine minus 1 is a minus 1. Chlorine 0 to plus 1 is a plus 1. If you take LCM of minus 1 and plus 1, it's just 1. Okay, so basically you do not need to change anything. It's just 1 and 1 there. Alright, because you got 1 and 1 there, then you have 2 sodium. I need 2 sodium. Alright, there's 2 chlorines. There's already 2 chlorine atom there. There's 2 hydrogens, so 2 hydrogen there. And 2 oxygen, there's 2 oxygen there, okay? So this is balanced as is, okay? So if you have what is it? For 1 mole of the X, so for 1 mole of NaOH, therefore, for 1 mole of NaOH, need 1/2 mole of CO2. Because if you want to make this 1 mole, you will divide the whole thing by 2. This is 1 in front, 1 divided by 2 is 1/2, okay? How about your Y? Your Y is Cl2 plus NaOH, but it's hot, okay? This will give you NaCl, which is chlorine minus 1. Perhaps I should write that better. There's your chlorine minus 1. I want to move this a little bit to the left so that I can get a bit more space. You also get NaClO3, which is your chlorine plus 5 species. This is what I mean by, like, you should have known this from your CAS studies. The chlorine plus 5 is a chlorine bonded to however many oxygen to give you a chlorine plus 5. Alright, CAS studies, yeah. And of course, we need to balance the equation, and we can use changes in oxidation number to do that. 0 to minus 1 is a minus 1. 0 to plus 5 is plus 5. If you take the LCM of 1 and 5, this is called lowest common multiple. I did this when I was in primary school, so I'm not sure when you did yours, okay? But you will have done it in school anyway. So I need to make it into a minus 5, so there's 5 of these, and there's only 1 of it because there's already a plus 5, so I just multiply by 1. So since I got this number already, so there's 6 sodium, so there is 6 Na, and there is 6 chlorine. 1 plus 5 chlorine is 6 chlorine, so I need only 3 Cl2. There's 6 hydrogen, so I need 3 of that. And the oxygen is 6 altogether. 3 oxygen plus 3 oxygen is 6. Sodium is balanced, chlorine is balanced, everything is balanced. Alright, using changes in oxidation number to balance chemical equation is not in group 17. It is part of redox changes in the AS syllabus for redox. Okay, and we want I might be wrong actually. I did say it was wrong, right? I stand corrected. I think I might be wrong. Let me just double check this. That's why it's important to check it, right? You see, okay. So therefore, for 1 mole of NaOH, for 1 mole, if you want this to be 1 mole of the species Y, then how many mole of chlorine will you have? You have 3/6 mole of Cl2. 3/6 is equal to 1/2, because you can simplify by dividing this by 3 and you get 1/2 mole of chlorine. Well, you need 1/2 mole of chlorine for 1 mole of X. You need 1/2 mole of chlorine for 1 mole of Y. Well, hot. This is a hot NaOH. This is cold NaOH. So really, they are the same. So they are not twice the number. So I was correct then. Okay, so 3 is definitely wrong. So 1 and 2 are correct. Okay, but ideally you should be able to write simple equations, and this question is just a bit tricky and a bit time consuming as well, especially if you can't do this very quickly. Yeah. So moving on to the next question. So when we have the yellow liquid NCl3, we stir them with aqueous sodium hydroxide, we get this reaction happening. What will be the result of this reaction? So you get a bleaching solution remains after the solution. Well, this is your Cl plus 1, this is your ClO minus, this is called chlorate 1, this is bleach. It's got the bleaching property, alright? So the fact that you forms it means you're forming bleach, alright? The nitrogen is oxidized, so let's have a look at NCl3. So it's N plus 3 times electronegative chlorine. Overall, molecule has no charge, so the nitrogen there is plus 3. This is nitrogen molecule, so it's N0. There's no other nitrogen. So you go from plus 3 to 0, that is not oxidation. You go from plus 3 to nitrogen 0, that is reduction. Okay, so number 2 is correct, number 1 is incorrect. You are really left with option C, alright? And you can think about option number 3 actually being correct, because the final solution gives a precipitate with acidified silver nitrate. That is down to test for Cl minus ever since your O-level or IGCSE. If you have done the practical, if you have opted for alternative to practical, they love to ask this in the theory as well. So this is your white precipitate that you get when you test for chloride using this colorless solution, acidified silver nitrate. It's a classic precipitation reaction because it is not a redox reaction. Silver plus 1, this is also silver plus 1, chlorine minus 1, this is also chlorine minus 1. Precipitation because aqueous solution give you a solid. Alright, so 3 is actually correct there, but without checking for 3, having checked for 2 being correct, 1 was incorrect, you have gotten C as the answer anyway. This next question, so this is about volatility. This is to do with how easy to boil. Okay, so going down that CO2, Br2 and I2, we know this is a gas, so at room temperature and pressure, gas, liquid and solid. So the boiling point increases down group 17, so it becomes harder to boil, therefore volatility decreases. All right, so these are all simple molecular structures, so we are not breaking the covalent bond, so you can rule out A straight away because this is talking about bond energy, which we are not breaking. We are not breaking the covalent bond because they are all simple molecules. What we are doing is simply breaking the intermolecular forces between the molecules when we boil these halogen molecules. So these intermolecular forces happen to be just van der Waals, and van der Waals depend on 2 factors. They only mention the one factor there, which is to do with the total number of electrons in the X2 molecules. So in fact, they are missing total to make it more correct. But since number 2 is correct and it's got nothing to do with bond energy, number 1 is wrong. We only left with option C really. Okay. So the other factor that a lot of students always forget is to do with the surface area of the halogen molecules. So your halogen gets bigger and bigger, so your surface area of the halogen molecule actually increases, so your van der Waals actually gets stronger, in addition to the total number of electrons increasing, and your van der Waals also gets stronger. Both of these cause the van der Waals to get stronger, you require more energy to bring them apart, okay, to separate the molecules further and further away. That's why your boiling point increases. Harder to boil, volatility decreases. All right, these are all stated as part of structure and bonding under factors affecting van der Waals forces. You have learned it in topic 3, and you have revisited it when you talk about halogens physical properties. So we come to the last question of this section 9.3 on group 17 chemistry. So which statements about the reaction of solid sodium bromide with corn sulfuric acid are correct? Okay, so we know in terms of oxidizing power, I know this is not being asked here. So the oxidizing power of the halogen chlorine, bromine, iodine. So chlorine is stronger oxidizing agent than bromine, which in turn is stronger than iodine. Your corn sulfuric acid is somewhere in between there. I don't know the exact position, could be there anyway. All right. But how far would the corn sulfuric acid oxidize the Br2 and I2? Because it's a stronger oxidizing agent than Br2 and I2. So this thing can oxidize Br minus to Br2. But how far would the sulfur get reduced as it acts as an oxidizing agent? In H2SO4, you get plus 1 times 2 hydrogen. You get sulfur, you get 4 times minus 2 for the oxygen. The whole H2SO4 has no charge. So the sulfur is actually plus 6. Realistically speaking, if you have seen my other tutorial videos on group on general periodicity, you have known that sulfuric acid contains sulfate, and that on its own is sulfur plus 6 straight away without you having to calculate all the time, because it becomes part of you. The more you use it, the better you get at it. Yeah? So we know that it doesn't go all the way to H2S. With iodine, you will get sulfur plus 4, which is SO2. You will get sulfur 0, which is sulfur solid. You will get sulfur minus 2, which is H2S. And that's because iodide is a much stronger reducing agent than Br minus. Br minus is not that strong, okay, but you will just stop at sulfur plus 4, which is SO2. It just stop here, okay. So you do get hydrogen bromide as a product. That is the first step, which is acid-base reaction, and this is the second step, which is the redox. All right, so if I show you the first step, it's basically corn sulfuric acid plus the NaBr. What you get is you get a salt, the acid donates a proton, you get HBr. That is not a redox, that is still sulfur plus 6. You can work it as an exercise. This is still Br minus 1, this is Br minus 1, this is sulfur plus 6. This is acid-base reaction, first step. Alright. Your second step is the one that will produce you the SO2, and it's the one that will react the HBr further. Okay, so your HBr can react further with corn sulfuric acid to give you SO2, because that's where it stops, and you will get Br2 and you get water because there's no other place for the hydrogen to go. Okay, so this is your using changes in oxidation number to balance chemical equation all over again. So sulfur plus 6 to plus 4, that is reduction, that is minus 2. Minus 1 to 0 is plus 1, that is your oxidation. So this is a redox reaction. If you take the lowest common multiple, LCM, the LCM between 2 and 1 is just 2. So what I do is I need to multiply this by 2, I need to multiply this by 1. When I multiply by 1, that means there's no change. This is just 1. Alright, when this multiply by 2, that means I will need 2 of this, because I have 2 times minus 1. Then I become minus 2 to 0. That will balance the plus 6 to plus 4, which is, sorry, I mean this to this will become plus 2, because you have 2 of it. This will balance out the minus 2 change here. This is 2H. They give you the, you need to balance this equation. They will give me 2 then. So 2 hydrogen, 4 hydrogen, 2 oxygen, 4 oxygen, 1 sulfur, 2 Br. This equation is balanced. This is your second reaction. It is your redox reaction. If you go to your first step, that was your acid-base reaction. Okay. So yeah, sulfuric acid is oxidized to sulfur dioxide. Oxidize. That is incorrect, because sulfuric acid is sulfur plus 6 going to sulfur plus 4 in SO2. That is a decrease in oxidation number, so that is incorrect. They are playing around with the words. They are trying to see whether you know what is going on here. Decrease in oxidation number is reduction, so it should be reduced. Same deal, the bromide ions is a Br minus 1, and then bromine is 0. This is an increase in oxidation number, so this is not reduction, this is oxidation. In fact, after having checked number 2 and making sure that number 2 was wrong, you will have come down to D being the correct answer. I said earlier this was redox, which indeed it is redox, as I've shown you here, as you have known in a theory paper how to balance the chemical equation. However, these are the wrong terms to use to define the changes. So that's it from me in this tutorial video. I hope that was useful. I covered quite a lot of concepts on redox changes as well, oxidation number as well, in addition to just group 17 chemistry. If you find that useful, do subscribe to the channel, check out the other videos on my channel, and don't forget to share the channel with your friends, your class group chat, your social network, to benefit more people whom you might have known and who might benefit from having learned from these videos on my channel. Thank you for sharing, thank you for watching, and see you in the next video.